Hello friends. So today I am going to discuss NASDAQ stock price analysis. So let's see. Just I have done practical work. So first I am going to the collect uh, data from Yahoo Finance. So we need to the install pip install Y Finance because I am doing and the Google Colab platform. So I am using the ID like so I am very comfortable at this platform, so I am using this one. So just everyone understand like what is the NASDAQ composite. NASDAQ composite is the like combinations of the number of stocks listed in the NASDAQ stock exchange, New York Stock Exchange. So this is the index. So now the exclamations the pip install Y Finance, and after that we need to some library look like this. So I am going to the import another two library. One is the matplotlib.pyplot as a PLT and import Y Finance as a YF. And now I am going to the import here NASDAQ stock price. IXIC is the stock price like a NASDAQ. So if you look here like a go IXIC, what is this? So you can see the IXIC. You look here is the future price, and this one NASDAQ future. Okay, NASDAQ futures price and NASDAQ index. Look here, could you see here? So similarly, just I have imported this data from 1st Jan 2000 to till today is the 2022. So we have imported. Now I want to see this data like a df.tel. So we can see here like a date, open, high, low, closing price, adjacent close price, and this is the volume price. Volume has been given. So until 19th December. So this data has taken like a 1 day back. Now if I want to print like a plot only the closing price, so we can see the closing price and look here. So how in 2021-22 most of the time market is going downward. Similarly we can also like plot the volume, so we can see the sometime it's a very big volume, it's going high and low is also. Similarly just I want to the plot both of them together, so we can see also it will be better to the understand what they are doing with the price and what is the relationship between price and volumes. Now after that we are I am using algorithms like a df.describe. Describe means these are the descriptions like a statistics. So first we need to the count here. So there are the 500 and 779 rows has been given. So we have gotten the mean like a 4610 and a standard deviations like a 3533. Minimum value is given like 1116 and 25% of quartile, 50% of quartile, this is called a mean, 75%. So this is called or the 3/4, and maximum value it has been given like a 16,120. I like to get a simple return like a you can get a simple return means differences between the today's and yesterday's price, and we can divide it by like a previous price and we multiply it with 100, so we can get the simple return. And similarly we can get a log return, so we can write the log previous day and divide by the like a log today's return, today's price and divide by the log yesterday price. So we have gotten the log return, and I am already plotted look like this return. So most of the time you will see here log return, it not going more than 10%, and it is not going below the 10%. So exactly if you want to watch this price, so most of the time you will see put your stop loss like 10%. It's as an index. So df log returns, just it has been given, and similarly we need to import the other library like a pandas as a pd, import numpy as a np, import cufflink as a cf, from the plotly.offline import iplot init underscore notebook underscore mode, and import pandas. Other we have already imported c1 as a sns, sci pi dot stats as a scs, import stats model dot api as sm, and import stats model dot tsa dot api as smt. df data frame, just I need to only the adjacent closing price, so I am I am using a ilock and like a slicing comma adj closing price. So we are taking as only adj adjacent closing price, and you can give the rename like adj underscore close at this one. Now we have gotten adj like it's simple return and log return, and now this we can plot easily log return and simple return, and similarly we can easily compare both of them. Now just another way how to get a realized volatility. This is the very important. So we can get the return np numpy dot squared and np dot sum x to the x square. So calculate the monthly realized volatility. So we need to convert all data, because we are collecting, I am collecting this data like a days by day, so we need to convert into the monthly. So I am going to convert this data into the monthly. If you need to convert into the weekly, we can put here the w. Yearly we can also convert here. So dfrv dot rename columns log returns. So now I am going to log return from a monthly data. So annualize the value, we can see the annualize this value. So df underscore rv dot rv will multiplied np dot sqrt 12, and this is the figure we have. I am plotted like a previous original price and a realized price. So we can see here this data is more visible because this is a monthly realized volatility. So you can easily understand these concepts of what are is just being. So we can see according to this one, so going like a prices is going down, and it might be possible, so it will go here till here, otherwise it can be break. So it be cautious in this market. So now the figure just a plot I have plotted like a adjacent closing price and another like a simple return I have taken, look like this. So look here, the stock price, it is going down, it is the simple returns, and now the log returns. So we can see all three together. Above each one of them like a presents a different series. So like a raw price, simple price, and the log returns, just we have discussed here. How to detect the outliers using the 3 standard deviations approach and mark them on a plot. So df underscore rolling, so df simple return dot rolling window 21. So rolling and dot aggregate, we are getting a mean and standard deviations. So rolling columns like a column drop levels first, and outliers like a join of mean and standard deviation, both of them. So we can define these data like a identify underscore outliers. We are creating the one functions, and row and n sigmas like a 3. Slicing x will equal to row simple return and mu equal to row mean sigma row standard deviations. Now I am applying here if x is greater than mu like a mean plus 3 star sigma, and also we can use here and x is less than mu minus 3 sigma like a 3 standard deviations, and return 1 and otherwise else zeros. So we see the outliers. We can see the first outlier axis will equal to 1 and outliers will equal to like a simple returns. So let's see what is the plotted look like this. It is a outliers like a red colors of ball. You can see here milli, and these are the normals. Okay, so outlier most of the time, because I have taken the 5%, so we can see here like a 5% look like. Did I see? I think the 5% we have taken, n will equal to, okay, so you can see, don't worry, I did write somewhere. So look here, this one like a color blue and normal outliers will equal to, and yeah, look here, similarly we are going to compare with like a VIX. So NASDAQ, and what is the relationship between the VIX and NASDAQ? This is a very important way to understand this market. So NASDAQ is and VIX, both column I have taken it together. Now log return we have already discussed, anyone, and we are going to get a correlations between both of them. So correlations means df log return, we need to the log return, and VOL return, like the one is the VIX return, another is the log return. So VOL means VIX, I have represented like as a variable, and we can see the minus 66% relationship between the NASDAQ and VIX. So it's really too negative. So how to calculate the normal probability density? So this is a way we can write the algorithms to get a normal distributions, and we see here, you can see here like a normal distribution, if the maximum is the 10% and minimum will be also look like maximum 10% and minimum 10%. So we have already seen. So I think you believe at this data, and another QQ plot is also going the 10% and below the 10% only once, only very few. So I think it is your forecasting is the really good. So df log return we have gotten here, and now n, I am taking the n will equal to 50 significance level. We want to check significance level like a 5%. So ACF SMT dot graphics dot plot ACF. So I have written this one like a autocorrelation is a negative, and similarly I am going to the compare like both of them, yeah, the absolute return and squared return. So we can see autocorrelations plots here, and DF the moving standard deviations like a 252 days is look like this, and DF like a 21 days. So here look like a IXIC this one. So I hope it is being a good and to get a return like this way. So I I think it will be the better to understand this price. And if you, so rolling we have taken like a 220 for 252 days, and here is the window 21 days. So now we compare both of the price, we can easily understand where is it going. So yeah, it is a very cautious soon, because market is going downward. So this is the better way to understand very deeply in this market. And I think so we try to understand NASDAQ stock price. So according to my knowledge, I describe is the one way. So there are so many ways. So in the future we will see the number of the ways, so don't worry. But this is the one way we can understand this market. Thank you for, I think it will be helpful for everyone. Thank you.